In this video, we shall discuss about the concept of hydrostatic law and its derivation. Imagine a small tank of water. Let's divide the water levels into multiple layers. Each layer has its own weight. As the depth increases, number of fluid layers increase. Due to this, weight increases and hence the pressure increases. This means the pressure increases with the depth. We must mathematically find the equation to find the pressure at any depth in the tank. Let's fill a tank with water. Consider a small fluid element called ABCD, which is located at a height Z from the free surface. Let's define the variables. Z is equal to height of the fluid element from the free surface. Dz is equal to thickness of the fluid element. P1 is equal to pressure on the top face AB. P2 is equal to pressure on the bottom face CD. A is equal to cross-sectional area of the fluid element. And lastly, W is equal to weight of the fluid element. From the figure, both P1 and W are acting downwards, whereas P2 is acting upwards. The pressure forces F1 and F2 are given by F1 is equal to P1 into A, F2 is equal to P2 into A. Finally, the weight W is given by W equals M into G. Further, it is written as rho into V into G. And finally, we will have W equals rho A dz G. From the figure, applying the concept of vertical force equilibrium, we get minus F1 minus W plus F2 is equal to 0. After substituting the values of F1, W and F2, we have minus P1 into A minus rho into A into dz into G plus P2 into A equals 0. Finally, we are left out with minus P1 minus rho into dz into G plus P2 is equal to 0. Also, from the image, it is evident that P2 is greater than P1. This means P2 can be written in terms of P1. Since pressure changes with depth, we write it as P2 equals P1 plus dou P by dou Z into dz. Hence, from equation 1, minus P1 minus rho into dz into G plus P1 plus dou P by dou Z into dz is equal to 0. After cancelling out, which can be further simplified into minus rho into g plus dou p by dou z is equal to 0. It can be written as rho g equals dou p by dou z or dou p is equal to rho g dou z. On a larger scale, we write it as dp equals rho g dz. Integrating both the sides, we get p equals rho into g into z. Here, rho into g is also called weight density or specific weight. Therefore, the hydrostatic law can be stated as the rate of increase of pressure in the vertically downward direction is equal to the specific weight of the fluid at that point.